Hello everyone and welcome to another video on African Tech Gurus. Today we are going to solve the task on more pointers and strings. The very first question that they have for us is they want us to write a function that concatenates two strings. So they'll give us two strings, and here they have given us the string hello and world. Those are the two strings that they have given us, and they want us to concatenate them together. We've already been given the prototype for this task 0, and this function will append the src string to the des string and overwriting the terminating null byte at the end of dest, and then adds a terminating null byte. And then at the end of it, it should return a pointer to the resulting string dest. So let's move and look at where we should create this specific file, which will contain the solution that will concatenate two strings. So we need to have it in our GitHub repository called LX Low Level Programming. The directory is this 06 pointer strings, and the file name is this. So remember, each and every single task has its prototype, and each and every task will always have a main file. And on my right over here, I have already created the directory. It's there. So if we list all the files, we will see, sorry, if we print the working directory, we should see that we already have this directory inside this GitHub repository. So the next thing that I usually do, I usually create all my prototypes all at once. And remember, we always use the putcar.c file, which is always provided. But in my case, since I'm not using the web terminal, I'll also need to have the putcar.c file. So the first thing I want us to do is I want us to put these files together before we actually do anything else or have any solution. So the very first thing that I want us to do is list all the files that we have, and so far we don't have any files. Remember, we always need to have a readme at the root of any new directory that we have. And what I'm going to do here, I'm just going to create a readme for this one, and I'll just have it as the name of the directory for ease, so that I don't have a lot of things to do. So let me just paste that here. Sorry, let me copy it again, and then we do that again. So this is what we are copying, the name of the directory as it is, and I will paste it there. Sorry, I am not in insert mode. I believe I am in insert mode. So now I think we can paste. Now we are good to go. So now I can save this file. And now the next thing I want us to do, I want us to create the prototypes and where they all should be. They should be in a file called main.h. And I usually have all my prototypes in one place before I actually do anything. So these are my prototypes. I hope you can see it. My prototypes are here. Everything is in this file. I usually do that so that my work is easier in advance, so that when it now comes to doing the solutions and solving the tasks, I save a lot of time, and by the time I'm getting to this point, I have actually understood what I need to do. So I'm just going to copy this, which contains all the prototypes that I need for this specific tasks. All of them are here, including the one for putcar. So I've copied that, and then now we can paste it in our main.h file, because here is where all prototypes will be saved and they will be fetched from here. The next thing I want to do is to create the putcar.c file. Putcar.c, so that my files also run correctly. So putcar.c, it's putcar.c, and it will have the function for putchar. So the function is this, and what this does is it prints every character to the standard output one by one. So let me copy that before we continue, and this is it. It's that simple, and I can paste it here. So now I feel confident and I can move to actually solving the first task, which is the one that we just looked at, this one. So you're supposed to create or write a function that will concatenate the two strings, and this is a prototype that we should use. So we are now just supposed to fill in the body for this specific one. So let me create that file, vi, and the name of the file. And I want us now to look at the solution and understand what it is doing before we do any other task. Before we move on to anything else, I really want us to understand what is happening in this specific task. So this is the solution. That whatever I have had, that is the entire solution. So let us dive and understand what is happening. So at the end of the day, this is the solution, and we are using the prototype. This is a prototype, and this prototype function is a function that will concatenate two strings, and here it will concatenate dest and src, and at the end of it, it should return a pointer to where the resulting concatenated string will be. So what does it do first? The first thing it does is it finds the length of the destination string, and it will use a while loop in this case, and it will increment the length of the string until it reaches the null terminating byte or character. Because remember, as we've mentioned time and time again, a sentence or a string ends when it encounters a null byte at the end of it. That is how the program knows we have come to the end. So what will happen is, once it has found the length of the destination string using this while loop, and that is happening in this case, the next thing is we are going to use a for loop. In this case, we're using now a for loop to append the src string to the des string, because remember we are concatenating these two, and at the end of the day, the destination string should contain the entire concatenated string. So here we're just using a for loop to append or concatenate the src string to the end of the dest string, and it is going to start at the index of the length of string. It's going to start at the length of string, which is here, and what it will do is it will increment both z, which is what the for loop is going to use because it's starting at z, and we are incrementing that over here, so it will continue incrementing, and the length of the string will be incremented until it also reaches the null terminating byte for src. So remember, it will continue appending and moving through the string one at a time, and here we have initialized z to 0, and as it is going through the string or iterating through the string, it is going to continue updating until it reaches the null terminating byte, where it will know now it has reached the end. And then now finally it adds a null terminating byte to the end. It adds a null terminating byte to the end. This is what is happening here at the end. Add that null terminating byte to the end of the string, such that that concatenated string now also has a byte, a null terminating byte at the end of it, which will mark now the end of that specific concatenated string. And eventually it is now going to return the pointer to the destination string, and this destination string is what now contains the entire concatenated string, which is the solution or the product for concatenating or putting these two strings together. So now I believe we can copy this and put it in a solution, run GCC and see if it gives us the correct output. So let me copy it from the main.h file and we put it here. I believe we are in insert mode. Yes, we are. So I'm going to put it here and then we save it and we run it. So the next thing we need to do is we need to run GCC. We need to run GCC. This is the GCC option that we have with all the commands. It's telling us we don't have 0 main.c file. We forgot to put that, so let us put that right now, and this is it. We need to create it, so let's create that first before we run GCC, and it should contain all that is contained in this gray box over here. So let us have that here and save this, and then now hopefully we can run our GCC successfully. So we have an error and it's telling us that we have an undeclared identifier or variable called j. This is supposed to be z because that is the variable that we were using. So let us quickly change that. That is in which line? Yes, it's in this line. So we can move to that line and change j to z because that is the variable that we had declared initially. We need to change it to z, yes, and then now I think we are good to go. We can save it. Now that GCC has run successfully, let's clear this so that we have enough space to see what is happening. Now we can run our executable file which has been produced and see if it will give us the same results. Let's go here and paste it. Sorry, yes, it will be that way with the 1.0. So it has run successfully and it has given us the output that we wanted, which is this. So we have hello and we have world, which are the contents of dest and src, and once we have concatenated, we have the hello world, which is the concatenated string, but world will still remain in src. It was contained in src. So now we are good to go, and now we can move to the next task. And here, before we move to the next task, then it tells us that we're supposed to write a function that will concatenate two strings again. Here we are also having a prototype that they have provided for us, and here this strncat function is similar to the first one that we have. The difference is that it will use at most n bytes from src, and src does not need to be null terminated if it contains n or more bytes. And similarly here what will happen is it will return a pointer to a string called dest. So the first thing I want us to do is create this one main file, which is the main file for this task, and it will contain the body that they have provided for us over here. So here we have this entire block of code that they have provided for us. So we copy that and put it here so that we are able to run and execute our solution successfully. So now, since we've done that, I believe we can move to creating this file which will contain the solution. So that is vi, and then we paste this solution over here, the name of the file, sorry, and now we can look at the solution and understand what is happening. So remember, there are very many ways of doing it. This is just some of the ways which I have found, and they made sense and they are pretty simple to explain. So what is happening with this code and function that we have here? So here we have a function called strn, which should concatenate two strings, which are dest and src, and they should do that up to the nth bytes and return a pointer to the resulting string. So in entirety, that is what the function is supposed to do. So the function first works by finding the length of the dest string. So it finds how big is this destination string, and it does that using the while loop over here. So as long as it has not encountered the null byte, it continues counting and finding the length of that specific string. After that, it now moves to a for loop. And what is this for loop doing? It will append the first n bytes of src string at the end of the destination string, which is the dest string, and it will start at the index of the length of string, and the length of string is this. So it will start at the index of dest, and it will start at the point at which it has counted up to, which will be the last or the end of the string called dest. And after that, it will increment both z and the length of the string, because here z is the count for the src string. So it will continue incrementing it, and it will only increment as long as these two conditions have been met, which is z is less than the length or the number of bytes in src, and we have not reached the end of the string src, which is the null byte. Similarly, or at the same time, it will also count the length of the string, which is now being concatenated together, which is dest, because that is where it will be added onto. So it will do this and continue doing this as long as this specific condition have been met. Finally, what happens next is that once the entire src has been appended depending on the number of bytes that are supposed to be there, it will add a null terminating byte to the end of that concatenated string. And that is what is happening here at the end. And finally, it will return the pointer to that specific location. So similar to the other one, and sorry I didn't mention this, it will always assume that the destination has enough space to hold both the dest and the src string for both of them. So that is what this will do in a nutshell. So let us copy this and see if it will run and give us the same solution as what is provided. So we are in insert mode already on this side, so we can paste it there, and we can escape and save it. And then now we can run GCC. This is the GCC, we can run it. We paste it here. Hopefully it will run with no errors, and after that it should give us an executable file for us to execute, and it will give us the same output as provided here. So let us run this and see. And yes, it's given us the same output. So the solution does exactly what they wanted us to do. It concatenates two strings, and it uses at most n bytes from the src string and returns the pointer. So now we can move to the next task. So the next task is telling us that we should write a function that copies a string. They have given us the specific prototype that we need to use, and our function should work exactly like this prototype that we have. Like this strnc, and what this is it's a standard library that has this function. So if you want to know more about it, you can run this to learn more of what this specific function is doing. So let us copy and create this file to main, because that is the file that is going to be used specific task, and the block of code that it needs is this one provided here below. So you need to copy the whole of it for it to run and for us to be able to execute. If you're using the web terminal, you don't have to copy it. So we've created that. Now we can move to the name of the file and create that file, which is this. This is the name. I will always insist or advise to copy the name of the file as it is so that you don't miss any specific character. So now we can move to the solution and understand what is happening. Here we have another prototype that they had given to us. And what is happening here is that this function, which is called strncpy, copies a string, and the string that is being copied is src to the destination. And it's only going to copy up to a specific number of bytes and return a pointer of that resulting or that destination string. So what happens here is it's going to use a for loop. This function, the entire function is going to use a for loop to copy the first n bytes, and n here is just standing in for a specific number depending on the number of bytes in src string. So the for loop is going to copy the first n bytes of the src string to the dest string, and it will increment the count of bytes or the number of bytes until either n bytes have been occupied or it has reached the null terminating character or the null terminating byte, which is usually at the end of the string. And here the specific string we're looking at is the src string. Now after this for loop has been executed, or it has done what it's supposed to do, if there is any space in the dest, then that function will pad the remaining space with a null character. So what that means is if there's a space in the function, in the string, let it have a space or a null character with it, such that it doesn't hang. And it is as simple as that. And here what will happen as well is at the end of this string, which is the dest string, what happens is we are going now to have a null byte, which will also mark the end of this specific string, and similar to the other ones, it's returning the pointer to that specific string. So now we can copy this and put it in our solution and run GCC. That is that. So now I believe we can run GCC, and this is GCC over here. We copy it and we execute it. Hopefully it will run with no errors whatsoever, and it will give us a executable file, and this is the name of the executable file, and we paste it there, and it has done exactly the same thing as what they wanted us to do on this end. So what is happening, if we recap, is we are creating or writing the body of a function that copies a string from one point to another. So it's as simple as that, and now I believe we can move to the third task that they have for us over here. So here I want to clear so that you have space. Here what we want to do for the next task is write a function that compares two strings. So here we'll be given two strings and we need to compare what's in both of them. So we need to create the main file for this task, and I'm going to do that right now before we create the file that will contain the solution. So this is the body of the main file that we have. Put it there and then we save it. Now we can move to creating the solution. So here I'm going to do vi to create file that you'll have the solution, before we look at what the solution has and what it is going to do. So let us look at the solution for this one. So this is it. So here we are having a prototype that compares two strings, and it's going to take in two arguments, which is the first string and the second string. And here we're just initializing a counter, two variables, one called counter and the other one called compare value. And what is happening next is we are initializing counter to start at 0. So what is happening here, we are supposed to define the body of this prototype that compares two strings, which is S1 and S2, and at the end of it, it should return an integer indicating their order. So that integer is this compare value, which is the same thing that will be returned here at the end. So how will this function work? It will work by using a while loop, and this is a while loop. And it will use this while loop to iterate through the characters in both S1 and S2, which are the strings that we have, and it will compare the characters at the same index in both strings. And if these characters are equal and neither string has reached the null terminating character or null terminating byte at the end, then the loop will continue iterating through the characters. So one by one, it will move to the next and the next. And if the characters are not equal, or one of the strings has reached the end by facing or coming to the null terminating character, then the loop will end. And the function will return the difference between the two characters at the last index, which was the last one that was compared. And that is just happening over here. Because here what is happening is it will check if there's a difference between the very last characters that were encountered at the last index, the two that are there. So if the function returns a value which is 0, that means if S1 is less than S2, and it will return a value which is greater than 0 if S1 is greater than S2, and it will return 0 if both strings are equal. So it will return the value that it has. So as a recap, it will return a value less than 0 if S1 is less than S2, and then it will return a value which is greater than 0 if S1 is greater than S2. And if these two strings are equal, then it will return 0, which will mean they are equal. So now let us copy this and put it in our solution, in our files that we run GCC. Put it here, and then now we can safely save it. And now we can run GCC. This is the GCC command that we have over here. And we paste it there, and it will give us an executable file. This is the name of the executable file. So let's just see if it will give us -15, 15, and 0. Yes, so it has given us -15, 15, and 0. So now we can clear and we can move to the next task. So the next task is they want us to write a function that will reverse the content of an array of integers. So whatever array of integers that we have, we just need to reverse whatever order that is there and print it out. And they've already given us the prototype, and n in this case is representing the number of elements in the array that we might have. So remember, the array might be different number of elements, but n is just going to represent the number of elements that are present. So let us create this that we have here, vi, and we paste this here. And this is the body of this function that they have provided for us. Sorry, it's starting from the very top. So let's copy all that all the way to here. And we paste it there. Yes. And we can save it. So let us now move to creating the file that will contain this solution, and it is called for rev.c. So for rev.array.c, yes, and paste it there. And now let's look at the solution and explain what is happening before we move to the next step. So here we also have the prototype, which is another prototype, which is called reverse array, and it's taking in two integers, a and n. And what it's going to do is it will reverse the contents of any array that it's been given. And how does it work? So it works by using a while loop. So the while loop is here. This is the while loop to go through or iterate through the array from the very beginning and end at the same time. And how it does this is it will also swap the values at each index until the middle of the array is reached. So it starts from both ends, both from the beginning and the end, and then swapping the values at each specific index until it now reaches the middle of the array. So this specific function will take in two arguments. The first one that I've mentioned is in a pointer to the array, and the array is called a, and it will take in n, which is the number of elements in the array. So this function will modify the contents of the array in place, and it will not and does not return a value. All it does is it rearranges them such that it's in reverse order. So to reverse the array, the function will use a temporary variable, and it's this one. This is the temporary variable, and it will use it to store the value at the current index that is now going to be swapped, and swaps the value at the current index and its corresponding index from the end of the array, and then it moves to the next index and its corresponding index from the end of the array until it reaches the middle. So it does this over and over again, swapping and changing the values at the index of the current index where it's at until it reaches the middle. It might be a little bit of heavy to actually visualize this, but that is what it does, and the function only stops at the middle of the array because the values in the second half of the array will have already been swapped with their corresponding values in their first half. So it's like just swapping things, because what was at the first index needs to go to the last index, so it will swap whatever is in the first and the last, and then move to the next indexes and then swap those and kind of move in an inward manner until it reaches the middle and everything has been swapped. So it's as simple as that, but at the same time it can be a little bit heavy to take in, but just sit on it for a while if it's still not sinking in. So let's paste it there and see if it will run successfully and give us the same output as whatever they have on this other end. So now let us run our GCC. This is our GCC. I'm going to put it here, and we run that. And now let us execute the executable file that we have at the end. And yes, so now if you look at the solution that we have, the first array had 0, 1, 2, and the very last value was 1337. But what has happened now is whatever was last, which is 1337, is now first, and whatever was first, which is 0, is now last. So what I was saying is it will take 0 and 137 and swap them. So 137 comes to the beginning, 0 goes to the very back, and the next thing that happens is it moves to the next index, which is 1, which will have 1 and 1024, and it will swap these two values at the current indexes that they are at with whatever is in the others indexes, and it will do this moving inward and inward until it reaches the middle. So that is that for that solution. So now we can move to the next task, which is always look up, and they want us to write a function that changes all lowercase letters of a string to uppercases. And they've already given us the prototype for us to use, which is this, and the main.c file. So let us create the main.c file for this task first, and we put it here. And the next thing that we need to do is copy this entire block of code that we have for us over here. And the specific string that we will be looking at is lookup. This is the string, that one that I have highlighted here. It ends with the exclamation mark. That's that. So that is a string that we need to change all lowercases to uppercases. So let us save this before we create the file that will have the solution, which is 5string to upper, which is this. Put it here. That is that. So now let us look at the solution and explain what is happening for us to be able to understand how best to approach this. So here we have a function which is called string to upper that takes in a pointer to the string, which is x, and it has a variable called length of the string, which is initialized to 0. So what is happening with this version of this function is that it loops through the string, which is called x, and it will check each character to see if it is either lower or upper, and it will only check as long as it has not reached the null terminating byte. So as long as this condition is met, it will always go through it over and over again. And the next thing that it will do is it will subtract from 32 from the ASCII. Sorry, I think I skipped something. So this is what I skipped. So what is happening here is it is checking to see if each character is a lowercase character. And if you remember the ASCII values for each specific character, they are in between 97 and 122. So it's going to check if each character is a lowercase. And if it is indeed a lowercase, so that means it is falling between 97 and 122, then it subtracts 32 from it. And what happens next is it will convert that character to its uppercase equivalent. And that is happening with what I have highlighted here in blue. And finally, what it will do is it will increment and continue doing this until the entire string has been converted to uppercase. And finally, once this has been met and we have changed all letters to uppercase, it now returns the pointer to the modified string which has all uppercases. So this is it. So let's put it here, paste it there, and save it. And now we can run GCC to make sure that lookup, which is what we had, has now been converted to uppercase. So let us put that here. It's saying that we do have an error just before the token, this token. So let's look at it and fix that accordingly. So we were missing a square bracket. So let's do that right now. This. So at the end of string, we need to have a closing square bracket and save it. So now let's see if it will run GCC. And yes, it has. So now we can run the executable file that we did have, and we paste it there. And yes, it worked as expected. All the values of the string that we have are now in uppercase. So now we can clear this and move to the next task, which is this. So what they want us to do is they want us to write a function that capitalizes all the words of a string. So here they just want us to capitalize the words themselves, the first letter of each and every word. And they've already given us the prototype function for us to use, and they are telling us what might be the separators for the words which will encounter. So if there is a space between words, if there is tabulation, if there is a new line, if there is a comma, if there is a full colon, a semicolon, all these characters, if they are present, that means this is one word is coming after that specific character. So let us now create these specific files. So let us create the 6 main file, which is this one. So we do vi and the name of that file, and we copy this entire block of code that they want us to have of here, which will contain the string that we should look at, and make sure that each and every single word in that string or that sentence is a capital letter. So we save it, and this is the string. This is what they want us to make sure that is in every single word in this string is capital letter. Sorry for that. So we move up there. So we want us now to create this file which will contain the solution vi, and this is the name. Yes, that is the name. So now we can move to the solution and see how it can be implemented. This one is a bit complex, but still at the same time it's not complex. It's just that the code might look a bit big, but it's not. So here we do have a function called cap_string. What it does is it capitalizes all the words or a specific string that it has been given to capitalize. It will take in a pointer to the string as an argument, which is this over here. So it will just have the pointer, which is the location or the address of that string that we need to make sure that each and every single word in it is capital. And it will at the same time return that same pointer. So how is it going to do exactly? It will do this by using a while loop to go through or iterate through the entire string, a single character at a time. Remember, they gave us all the characters that they wanted us to look at, and make sure that these specific characters, if they are encountered, it means that whatever is coming next is a word. So these are the word separators for us to look for. So at the end of the day, the function will loop or iterate through the entire string, one character at a time. And what it does is, if the character that it has encountered is the first character of that string, or if it is met by a space, or if it is this is the space, or if it is met by a tab, or if it is met by a new line, if it is met by a comma, if it is met by a semicolon, a full stop, a question mark, all these characters, when it meets this character, it knows that, or the function will check whether that specific character is lowercase. So because all these characters that come after these specific characters need to be capital, so it first needs to check whether they are small letter or lowercase letter. So if it sees that it is indeed a lowercase letter, what does it do next? It will capitalize that letter by subtracting 32 from its ASCII code. The other thing that it does is, otherwise, or if the character is not either the very first character of this string or is not followed by any of these special characters that we have mentioned, then it will check if that character is uppercase, because it should not be uppercase. And if it is indeed an uppercase, then it needs to change it into a smaller or lowercase by adding 32 on top of it. So overall, at the end of the day, this function will provide a very simple and efficient way to actually capitalize all the words of a string and make it readable and deliver the solution that they want us to deliver. So let us copy this and carry out what we need to do. So we need to put it here. And we need now to save it next and run GCC. This is the GCC command with all its options. for it to give us an executable file. So you paste it there, and it has indeed run successfully. So let us see if indeed it has done what we needed it to do. So we paste it there, and indeed it has actually done that. So anywhere that it had a space, it has made sure that the word following that begins with a capital letter, with it being a full stop, that the next thing is a capital letter. It actually delivered what we wanted it to do. So now we can clear this and move to the next solution, the next task, and give it solution. So here we're supposed to write a function that will encode a string into 1337. So here they've also given us that letter A, both uppercase and lowercase, should be replaced by the value for letter E, both capital and lowercase, replaced by 3, and so forth and so on. And they are telling us that you can only use the if statement once in our code, and you can only use 2 loops in our code, and you cannot use a switch statement in this case. So as we've done before, the first thing we need to do is create the main file for this specific task and have the body that it should have, which is this. And here we will have a string, and this string will have the characters that need to be converted to 1, 4, 7, 3, whatever it is. Yes. So now let us save this file. And now the next thing is we create the file that should have the solution of this task. And there it is. So now we can look at the solution and explain it and understand what is happening here. So in this specific task, what we need to do is we need to replace all these characters that we have, A, E, O, T, and L, with the values that they have given us over here. So what we have is a function as well that we have here, and it's going to take in a pointer to an array of characters, and the array of characters is S. And how is it going to do all this? So it will start by using a while loop to just iterate and go through each and every single character in the string that it has, or the one that we have been provided, and it will go over each character as long as we've not met the null byte at the end of the string. So it will take that string as input, iterate through it one character at a time, as we've mentioned, and it will check that for each character that it meets, has it been provided as some of the ones that we have in our case, and those ones are these ones provided here. And if it matches any of this, then it will replace it with the corresponding number that needs to be replaced with it. And if not, it simply continues and it moves on. So at the end of the day, what this will do is it will just go and iterate over the entire string one step at a time, just making sure that all these characters, if they are present in the string, are replaced by their corresponding values that we have provided here accordingly. And at the end of it, it will return the specific string or a pointer to that specific string. So let us copy this as it is and put it in our solution and see if it actually does as expected or not. If not, we will edit it and work on it again. So we paste it here, we save it, and now we can run our GCC, and we paste it there. It will give us an executable file called 7137 71337. paste it there, and indeed it has. So initially we had expect the best, prepare for the worst, capitalize on outcomes. So anywhere it has encountered a small e or a capital E, it has actually replaced it with 3, as you can see over here, and so forth and so on. Anywhere it has met a T, either small or capital, it has replaced it with a 7. So it has actually done exactly what we wanted it to do, and we can now say that we've completed all our mandatory tasks successfully. Hopefully, you'll be able to understand the concepts and all that is happening. It might take a bit of time also to get used to it, but don't feel discouraged. Just keep on practicing to code, looking at different point of views of how to understand the concepts, and at the end of the day, you will be better placed. Um, Thank you for watching today's video. I appreciate you so much. I appreciate you so much. If you have a friend, please share it with them if they're struggling, so that we all are able to understand the concepts. If you liked today's video as well, please give it a thumbs up, like and share. It will really support and help us. And if you've not subscribed, please go ahead and hit the subscription button and hit the notification bell as well, so that each and every single time we upload a video, you are immediately notified. Thank you so much for watching today's video, and until next time, happy coding.